Hi everyone, welcome back. I've brought to you another interesting GFG question problem of the day. Rat in the maze. This is a very basic recursion problem. It is also quite famous. This is also simple if you understand it. It is good to understand the concept of recursion. Recursion means a function that calls itself. It is a problem solving technique that breaks the problem into smaller subproblems and finds the solution to the base case and uses that to get the solution of the bigger problem. So we will see how recursion works and how it is used in this question. So the question says a rat is placed at the starting cell 0, 0 and there is a matrix of order n cross n. Some cells are 1, some cells are 0. 1 means we can move there, 0 means we cannot move to that cell. We have 4 directions up, down, left, right, and we have to reach the leftmost and bottommost cell, rightmost and bottommost cell, that is the last cell of the grid. So we have to find out all the possible paths. If there is no possible path, then we do not have to show any path. Means this in this question we have to find out all possible paths to reach the last cell of the grid. So how to do this? First of all, we can see that any cell we reach, we have 4 possible conditions. That means 4 calls we have to make every time. So this suggests that we can use recursion as the subproblem is same as the main problem. Let us move to the solution. The solution is very easy. First of all, we can keep an array list L to store all possible paths. Then we have initialized it. We have given an array list. Now we make the first recursion call. We have to call our function ret. Am is our matrix. 0, 0 are the starting coordinates where we start. That's the first cell, and the path is initially blank because we have not taken any move. So this is our recursive function ret, and int a is our 2D matrix, I, j are the initial coordinates, and string answer is the path that we have taken till now. Now what shall be the base conditions? For recursion, base conditions are very important as these conditions define when our recursion will terminate or move back. So first base condition, we can see that if we move out of the grid, that is not a possible solution. So that is a base condition. We have to terminate it and return from there. Or the second thing is if the cell is blocked, that is it is 0, so we have to move back. So the conditions are if I is less than 0, that means it is out of grid, or if I is exactly equals greater than equal to matrix dot if row reaches out of bound, or if column reaches out of bound, j is less than 0 or j is equal to length, greater than equal to length. For the second condition we saw was if the matrix cell is blocked, it is 0, so we have to return from there. Another base condition is our answer if we reach the last cell of the grid, that is I is equal to length minus 1, j is equal to a0 dot length minus 1. Then it is our answer, so we can add the answer to our final list, answer list, and return from there. Also, how we have to move in the recursion. First of all, we will mark the cell as visited so that it does not go into a loop, infinite loop. If do not mark this as 0, then it will again when it reaches suppose down, and we have not changed it, so it will again move up, then down, then up, then down. This will go into an endless loop, so we have to mark it as visited, that is 0, that means we have blocked it. After that we have 4 directions, so 4 calls. For every call we have to change the coordinates. If it is moving right, so column increases. If it is moving down, row increases. If it is moving up, row decreases. If it is moving left, the column decreases. So these are the 4 calls for 4 directions. And after we return from the 4 calls, this means that our work is done, so we change it back. This is backtracking concept, so we change it back to 1. That means that we have tried all possible paths here. Now we return it back to the initial position how it was earlier and return back. So after this recursion executes, we will get all our answers, valid paths in the answer list, so we can return that answer list. This is the simple basic recursion question. I hope you guys would have understood it. Thank you for watching this video. Have a nice day.